Assalamualaikum. My name is UMMI RAIHANAH binti ROSLEE and my matric number is AA190544.
Hi, Assalamualaikum. My name is Izzah Khalidah binti KHALID. My matrix number is AA192058.
Okay, hi. So let's begin with lab activity 1. So we need to develop the diagram figure 1 in fluid sim software. This one, electro-pneumatic circuit, electro-hydraulic circuit. So this one is my electro-pneumatic circuit and electro-hydraulic circuit. Both circuit has same electrical diagram, but the difference is between pneumatic circuit and hydraulic circuit. So firstly we need to click run button for start the simulation. So as we can see here at the rest position, the air already flow through this part, but the air have blocked with the air compensation valve. So the cylinder not extend yet, so we need to press the push button so the cylinder will expand. S1 is a push button, while 1B1 is brake or limit switch. The function of limit switch is will automatically open when it reaches its limit. Okay, when we press the push button, the current will flow through the relay contact K1, so the relay will energize and the switch, and the switch will become normally closed. When the circuit will be closed circuit, it will trigger the valve solenoid, and then solenoid here let the air through the piston. When it's reached its limit, the limit switch will automatically open. Okay. Okay, for the hydraulic circuit, it is same, but we use tank because hydraulic is using hydraulic oil for the source. Click the run button for start the simulation. So we press the push button here, and when it's reached the limit switch will automatically open. In this one, the speed of response is more speedy because it using air, while in hydraulic circuit is a bit slowly because it using hydraulic oil, so it takes time to piston to extend and back to the normal. Okay, for the observation lab activity 1, observation 1, briefly discuss the function of the two components circled in red below, this one and this one. Okay, the first
The first component is named tank. Tank is a container to store the fluid required to supply the system and protects the fluid from getting contaminated, which is critical to ensure the hydraulic system function optimally and also to dissipate heat. Okay, the other one is an air compressor check valve. Air compressor check valve is to let air flow from one side to the other while blocking air flow in the opposite direction. This one is to let air flow from this side to the other and while blocking air flow in the opposite direction. Okay, next question for lab activity 1. Question 1. Describe the difference between electro-pneumatic and electro-hydraulic system. Okay, for the electro-pneumatic system, pneumatic cylinders are driven by air pressure. Air can sometimes be less efficient as a power source because it can be compressed, causing the actuator to lose pressure. While electro-hydraulic system is using hydraulic cylinders are driven by fluid pressure, it can hold torque and force without continuous application of fluid pressure from the power source. This is because fluids are not compressible. The other one is in electro-pneumatic system using air service unit is to provide the pneumatic system with a well clean and lubricated and regulated compressed air, while in electro-hydraulic system is using pressure relief valve is to control or limit surge of pressure within pipelines, acting as protection for the system and defending against instrument or equipment failure. Okay, next question. Okay, question number 2 is to describe an industrial application for electromagnetic and electro-hydraulic system shown in figure 1. Electro-pneumatic and electro-hydraulic systems are using electrical technologies to control the supply used as the working medium. Electrical devices such as solenoid, limit switches, valve and relays are some of the mechanisms used. The solenoid operated valve supplies are one of the solenoid pilot operated type. In this type of valve, the electric current flowing through the solenoid coil produces a magnetic field that moves a plunger. Moving the plunger opens a flow path and allows the pilot pressure to act on the valve spool. Note that the spool of the valve will not move if compressed air or fluid is not supplied to the valve, even though an electric current flows through the solenoid.
For lab activity 2, the left side is a pneumatic diagram and the right side is the electrical diagram. When we run the simulation, we can see that the air will flow through the valve, which is inlet port 1 to the outlet port 2 and the back part of the cylinder. For electrical diagram, IB1 is already in normally closed circuit and it will energize the K2 relay coil and K2 relay contact become closed circuit. It causes the 1M1 solenoid valve to get energized and make the valve to be in this position. But when we manually push the valve will move to the right and the air will flow through the valve and go to the front part of the cylinder. It causes the piston extend because the air fills the actuator. So as we can see, the piston is at the IB2 position. Okay, this make the IB2 switch, which is a limit switch here, was changed from the normally open circuit to the normally closed circuit. It will energize K3 relay coil and it causes K3 relay contact become closed circuit. Next, 1 and 2 solenoid valve will energize and make the valve move to the right. Next, we will move to electrical diagram. When we push the DINTI switch here, which is S1, it will energize the relay coil K1, and at the same time, K1 relay contact will change from open circuit to normally closed circuit. This action will let the electrical current flow through the rung 4 and energize the 1M1 solenoid valve. So the valve in pneumatic diagram will move to the right, as we can see here. So this is the simulation. So the piston will extend to the 1B2 position. It causes the 1B2 switch, which is in electrical diagram here, to become closed circuit and energize the K3 relay. While at the same time, K3 relay contact will change from normally open circuit to normally closed circuit and energize the 1M2 solenoid valve and make the valve back to its normal position. And now we move to observation lab activity 2, question number 1. Just state the name of component 1B1 and 1B2. 1B1 and 1B2 is limit switch, which is 1B1 is normally open limit switch and 1B2 is normally closed limit switch. Question number 2. Briefly discuss the function of 1B1 and 1B2. A limit switch is an electromechanical device operated by physical force applied to it by an object. Function of limit switch is to control the electric current flow through when the switch S1 is pressed. Function for 1B1. 1B1 switch will change from normally open circuit to normally closed circuit when it reaches the limit. This action will make the K2 relay coil energized and K2 relay contact become closed circuit. It causes 1M1 solenoid valve to get energized. For 1B2, when 1B2 is reached the limit, it causes the 1B2 switch to become closed circuit and energize the K3 relay coil. At the same time, K3 relay contact will become closed circuit and energize the 1 and 2 solenoid valve. Next, for observation lab activity 2, during the simulation, a symbol with an arrow, which is here, always appear next to the component in the electrical diagram. Describe what do you understand when you see the symbol. It represents the current flow through the circuit. When the current is not flowing through the component, the arrow will not appear. Next, for question part, number 1, discuss the importance of component A in actual industrial application. Okay, so A is an air service unit. The function of this system is to remove dust, particle, moisture, humidity, and so on from the compressed air. Okay, there are several parts in air service unit, which is called an air preparation system. So what is the part? First one is air filter, pressure regulator, and lubricator. Okay, the function for air filter is to remove impurities such as dirt, sublimation water in compressed air before it is delivered to the pneumatic component. The function for pressure regulator is to adjust the pressure according to the needs of the system. For lubricator, it will spray lubricated oil in compressed air to be carried to moving parts such as directional control valve and piston. For lab activity 3, this one is a pneumatic diagram and this one is an electrical diagram. When we run the simulation, the valve is already in the left position. We can see the compressed air can flow through the valve, which is inlet port 1 to the outlet port 2 and go to the back part of the cylinder. Now the space is filled with air and cause the piston retract and be at 1B1 position. The remaining air here at the front part of the cylinder will be released through the exhaust port, which is 5. But when we manually push the valve, it will move to the right. The air will flow through the valve and go to the front part of the cylinder. It causes the piston extend because the air fills the actuator, and the remaining air will be passed to the exhaust. So that is for pneumatic diagram. For electrical diagram, the red line represents the current flow. At the electrical diagram, the counter has been set to 5. Function of DINTI switch is to change over contact are used to close one circuit or open another circuit. Function of DINTI switch is to change over contact are used to close one circuit and open another circuit in one switching operation. They keep the selected position. The switch position remain unchanged until a new switch position is selected. First, we need to see the simulation. When we press the intent switch, current will flow through C1 and energize the relay coil K1. K1 relay contact here will become closed circuit. At the same time, current will flow through the magnetic proximity switch, and inside the proximity switch there is normally closed circuit. So the current will flow through it and cause K2 relay coil energized. K2 relay contact here will become closed circuit, and 1M1 solenoid valve and 1M1 solenoid valve will be energized. That is for 1B1. So next for 1B2, when we press the intent switch, current will flow to C1 and K1 relay coil. K1 relay contact will become closed circuit. At the same time, current flow to 1B2 and it will change from normally open circuit to normally closed circuit. So the current will flow through it and go to the K3 relay coil. So K3 relay coil will energize and K3 relay contact will become closed circuit. 1M2 solenoid valve is energized. The counter will start counting for 5 pulses. When we press the intent switch, we can see that the movement of the cylinder will extend and retract for 5 times. The counter will be count down, which is it will reduce to 4, 3, 2, 1 until 0.
Okay, for lab activity 3, observation. Number 1, tabulate the list of components used in figure 3. So this first one in pneumatic diagram. We are using component. This is compressed air supply unit. This air service unit, double acting cylinder. This one and 5 and way valve. Electrical connection 0 volt in electrical diagram, 24 volt, electrical connection 24 volt, detent switch, push button, mag switch, magnetic proximity switch, relay, valve solenoid, relay counter, brake switch. Okay, next for the observation lab activity 3. Number 2, explain the function of S2. S2 is a push button, will act as a reset button for the counter to set back from 0 to 5. Next, for the question number 1 is the position of 1B1 and 1B2 in figure 3 is different from figure 2. By referring component A and B below, both types are practical for 1B1 and 1B2 in figure 3. Explain your answer. So the component A is a limit switch. It is a switch operated by the motion of a machine part or presence of an object. It is actuation provides an electrical signal that can cause a system response. When there are mechanical response at the other component in the circuit, the limit switch will be actuated. While component B is a magnetic proximity switch, non-contact proximity device that are used to detect magnetic objects near the component. It will show it is a response either it become actuated or not. Okay, that's all from us.